Power to the truth. This is Margo. This is Saturday, March the 23rd, 2019, 5:23 p.m. Pacific Time, United States of America. So we're going to briefly do an update on the two cyclones in Australia, and then I'm going to go over the articles that I was going to share yesterday, but I'm going to go over those. We've got a bunch of stuff on the Arctic and about the oceans warming, and then we'll do earthquakes. So that's our format for today. So here we have NASA Worldview from today, and looking at the satellite image here, we can see that Trevor is well inland by now. It's actually dropped to a tropical storm or tropical low, according to the Bureau of Meteorology. And Veronica is making landfall. And you can see that Veronica is very tight still, and it looks very well organized and very well formed, and it's coming in with a fierce punch here for for Australia. So there's that. Also on Earth Null School, we can see this is where Trevor is right now, and we can see it slowed down a lot, but it's bringing a lot of rain. And here's Veronica right now, so it is making landfall. Right there, and it's pretty fierce, it looks like. And so now we're just going to briefly go over what's going on with this. Close that. This is from the Bureau of Meteorology from Australia. I will leave the link below. These are the current tropical cyclones, and they've got them listed here. Here's Trevor, it's showing as a low, and here's Veronica, and it's showing as a category 3. So a severe tropical cyclone category 3 right now as it's coming in. So this map was created on March the 24th at 20 minutes UTC. So it's the 23rd here in the United States, but they're already into the next day because of the time zones and everything. So this is probably the best website to see forecasts. Here we can see the forecast map. This is details for tropical cyclone Trevor, and we can go here and we can see where it's been. It was a category 4 up here at 11 o'clock on March the 23rd, and then it's moved on in, and then it quickly dropped to category 2 by 7 p.m. on March the 23rd, and then by 10 p.m. it had dropped to a category 1, and by 1 a.m. it was a category 1, and by 4 a.m. it was a tropical low. And so it's still going to be tracking inward and circling down to the southeast with a severe weather warning for all of these areas that are in the map. So here's what they're saying, that they're going to have gales within 24 hours. It was a past cyclone, and now it's a low, and The forecast path shown above is the Bureau's best estimate of the cyclone's future movement and intensity. There's always some uncertainty associated with tropical cyclone forecasting, and the gray zone indicates the range of likely tracks of the cyclone's center. Due to the uncertainty in the future movement, the indicated winds will almost certainly extend to regions outside the rings on this map. The extent of the warning and watch zones reflect this. This product is designed for land-based communities. Mariners should read the coastal waters and high seas warnings. And the headline is, Tropical Cyclone Trevor has weakened into a tropical low over land west of Brunette Downs. Refer to severe weather warning. Areas affected, warning zone none, watch zone none, and then they canceled all of these zones. The inland parts of Carpentaria District, south of Cape Crawford, and northern Barkley District, including Creswell Downs and Brunette Downs. Here's the details from ex-tropical cyclone Trevor at 3:30 a.m. Intensity tropical low, sustained winds near the center of 55 kilometers per hour with wind gusts to 85 kilometers per hour. And here's the location with the latitude and longitude, and the movement is south-southwest at 22 kilometers per hour, so it's moving pretty quick. And they're saying sustained gales are no longer expected near the center of ex-tropical cyclone Trevor. However, damaging and locally destructive wind gusts are still possible with thunderstorms. Heavy rainfall is likely to cause significant stream rises and localized flooding in the southern Carpentaria and eastern Barkley districts, extending into the northern Simpson district on Monday. Tides between Port MacArthur and the NT Queensland border will remain significantly above the normal high tide on Sunday morning, with large waves on the shoreline. Severe weather warning is current for these conditions. Refer to that product for more information. A flood watch has been issued for Carpentaria coastal rivers, Georgina River, Simpson Desert, and the Barkley. And they recommend to follow direction and advice of local emergency services. Residents in the severe weather warning area should prepare for severe weather, an increase in damaging winds and rain, and are to take shelter as conditions deteriorate. And then here are the times, and here are the forecasted out on the times and dates, and the intensity, and the longitude and the latitude, and expected estimated position accuracy within like 35 kilometers and so forth. And it says there will be no further forecast track maps issued for this system. And so there's that. So they've downgraded that. Now it's a tropical low and is just moving along, dumping a lot of rain, and it still has some damaging winds. So, but it's moving inland. Then down here, details for severe tropical cyclone Veronica. We can click on the forecast tracker map, and this was as of 8:08 this morning, or Sunday morning. And it's red, and it's hit land, and it's moving on in, And so here are the towns that are affected by it. And of course, it's the worst part is right in here where it's red. And it's a tropical cyclone 3 here, 3, 2, and 1 on the edge. But then a 4 all the way out here. That's probably because that's still over water. So Port Hedland, looks like Whim Creek, Roebourne, Karratha, and Dampier are in the red zones here, red and pink zones. So there's that. Headline: Severe Tropical Cyclone Veronica is causing destructive winds and increasing heavy rainfall on central Pilbara coast between Dampier and Port Hedland. Port Hedland has registered 177 millimeters of rainfall overnight. I don't know how many inches that is. It sounds like a lot. Warning zone: Wallal to Mardi, including Port Hedland and Karratha, and adjacent island areas including Panawanika. Details: as of 8 a.m., intensity category 3, sustained winds near the center of 155 kilometers per hour with wind gusts to 220 kilometers per hour. Here's the location with your longitude and latitude. Movement south-southeast at 10 kilometers per hour. So this is a much slower moving storm than Trevor. The cyclone's core has reached land approximately midway between Karratha and Port Hedland. The center is forecast to cross the coast this afternoon. Hazards: destructive winds with gusts exceeding 125 kilometers per hour have developed along the Pilbara coast between Dampier and Port Hedland and are forecast to extend to adjacent inland areas during Sunday morning. Gales with gusts to 100 kilometers per hour have developed between remaining parts between Mardi and Pardue and may extend to other coastal communities between Wallal and Pardue by Sunday afternoon. Gales may extend to adjacent inland areas including Panawanika during Sunday afternoon or evening. Very destructive winds with gusts in excess of 165 kilometers per hour are expected near the cyclone's center as it approaches the coast during Sunday. Veronica may be traveling more slowly than a tropical system as it nears and crosses the coast during Sunday, and as a result, communities in the path of the cyclone should prepare to shelter from the destructive winds for an extended period today. Widespread, very heavy rainfall conducive to major flooding is likely over the Pilbara coast and adjacent inland areas Sunday and into Monday. Heavy rainfall is expected to result in significant river rises, areas of flooding, and hazardous road conditions. Some roads may become impassable, and some communities may become isolated. Flood warnings and watches are current. Please refer to, and then it gives their website for the warnings for further details. People along the Pilbara coast are warned of the potential for a very dangerous storm tide on the high tide 1 p.m. at Port Hedland as the cyclone approaches the coast during Sunday. Tides are likely to rise significantly above the normal high tide mark with damaging waves and very dangerous coastal inundation, particularly to the east of the cyclone center. Recommended action. They have the following community alerts. Red alert for people in or near communities between Pardue and Mardi, including Port Hedland, South Headland, Wim Creek, Point Sampson, Wickham, Roeburn, Karratha. Dampier, but excluding Marble Bar, need to go to shelter immediately. Yellow alert, people in or near remaining communities between Wallal and Pardue and inland to Marble Bar need to take action and get ready to shelter from a cyclone. Blue alert, people in or near communities for parts of the inland Pilbara, including Panawanika, need to prepare for cyclonic weather and organize an emergency kit, including first aid kit, torch, portable radio, spare batteries, food, and water. All clear people in Nullagine are advised that there is no longer the risk of gales. And so here are the times, the forecasted times through the 27th, and the intensity category, and then the location of the longitude and latitude. They're showing it as a tropical low. The furthest south is 21.2 degrees south latitude, and the longitude of 115.9 degrees east. That's what they're expecting by the 26th. So that's a couple of days off. And the next forecast track map will be issued by 9 a.m. on Sunday. So this is probably the most up-to-date website you can track these storms with. So I'll leave the link below on that. So we're going to keep everyone in our prayers for that. Now, and I'll leave these other links. This is a news article about the Cyclone Trevor hammers at the mainland, and then these are Trevor Storm Tracker and Veronica Storm Tracker too. So I'll leave those links, but I'm not going to go over those because I want to go over some of these other articles now. But you got the picture. They're in the middle of having a big event down in Australia. So my first article I want to share today is from carvinbrief.org, and this came out on March the 22nd, and it says Arctic sea ice winter peak in 2019 is 7th lowest on record. And it says Arctic sea ice has reached its maximum extent for the year, peaking at 14.78 meters square kilometers on March 13th. It is the joint 7th smallest winter maximum in the 40-year satellite record, tied with 2007. The preliminary estimate from the National Snow and Ice Data Center in Boulder, Colorado suggests this year's winter peak is the largest since 2014, but it is still 867,000 square kilometers smaller than the 1981 to 2010 average. So they're talking about the extent. So they're saying the extent is the largest that they've had since 2014. So that doesn't cover thickness, it doesn't cover concentration, it doesn't cover volume. They're just talking about extent. Continuing, the most remarkable feature of the Arctic sea ice this winter has been the very low cover in the Bering Sea. Following similar lows there in 2018, this is unprecedented in at least the satellite era. And it's had significant impacts to coastal communities and marine ecosystems. And we've talked about that. I've shown articles about the Bering Sea being ice-free and all this stuff, and it's too soon and all that. And I've already shown all of that. Meanwhile, in Antarctica, sea has already reached its minimum extent following the summer melt season. Provisional data suggests that sea ice reached 2.47 m square kilometers on both February 28th and March the 1st, putting it 7th in the list of lowest summer minimum on record. And so now winter has ended. Winter turns into spring in the northern hemisphere. Arctic sea ice stops growing and reaches its peak extent for the year. This marks the end of the half-year ice growth season that started with the sea ice minimum, the 6th lowest on record in September of last year. Scientists use satellites to monitor sea ice extent, recording the size and date of the annual maximum when it peaks each year. Anyway, so I'll leave the link below if people want to look at this. So they're saying, well, and then Zach Labe shows a chart for sea ice annual maximum. Here's his chart. So and then they talk about the Barents Sea, and then the Bering Sea, and Bering Sea ice extent, and we're at the lowest. This green line is for 2018 to 2019, and we're showing that that is at the lowest for the Bering Sea ice extent. And I showed that where, you know, in 2 days all that ice just went away, and there was a blackout on the data for 2 days, and then it came back, and then the ice, there was a whole bunch of ice gone. I already showed all that. There's the Antarctic sea ice extent, and it's at its lowest. So I will leave the link below so that people can look at that, but that's kind of a big one. And we can also go up to the Arctic, and what they say, March the 13th. Let's go to March the 13th, and we're going to turn on this sea ice concentration, and we can see the extent along with the concentration with this. I'm going to turn on the blue marble layer so that we're not distracted here. And so here's what it was on the 13th when it was at the maximum. And so here they counted all of this blue as extent. They counted all of that blue, and remember that the blue is very thin. and like this blue is at 48% concentration. And like this darker blue over here by Novaya Zemlya is at 13% concentration. So that means it's really thin. So they count everything, you know, a little skim of ice on the top, a little skim that you could just run your finger through and separate it. They count that as extent. So, but you know, we've been looking at the Navy military model for sea ice, and it's very thin. So there's that. So we're gonna leave that for now. I'm gonna close that out. So, you know, they're just trying to make people think that everything is okay, and it's not. It's just not okay. It's not going to be okay. Okay, here is, this is from a climatologist, Brian Brettschneider, and this has been passed around. This is big news in the climate change community. This is on his Twitter page. Oceanic heat in the upper portion of the ocean has spiked the last few months. This chart shows the global integrated average potential temperature departure from 1981 to 2010 monthly averages in the top 105 meters using the NICEP-GODAS dataset. So here it is, February 2019. And so we can see these were ocean temperatures down through all the measuring periods. These are the years. Here's January 2019. Here's January 2018. These are, each one is a year. January 2017. And it's all January, but it goes all the way back to 1981. Where they were measuring the heat, the oceanic heat in the upper portion. So there was a spike here in, it looks like 1998. There was a spike in the heat, and then it went back down, and then it's been up and down, and then the highest before this year was, it looks like, in 2016, and then it went back down a little bit, and then it jumped all the way up here. So the highest it was before this year was at 0.3, and this is departure from the average in Celsius. So this is at almost at a 0.5. So it's almost half a degree higher than normal. So I'd say that's significant. So there's that. Oh, and he measured it from the data set domain is 66 north to 74 degrees south. So it does not include the north and south poles. It includes everything else basically. So there's that. Next, staying with the ocean, this is from ETH Zurich. Ocean sink for man-made CO2 measured. And this came out on March the 14th. An international research project led by scientists from ETH Zurich has determined the amount of man-made CO2 emissions taken up by the ocean between 1994 and 2007. And this is 2019, so they're talking about the CO2 that was taken up by 2007. Not all the CO2 generated during the combustion of fossil fuels remains in the atmosphere and contributes to global warming. The ocean and the ecosystems on land take up considerable quantities of these man-made CO2 emissions from the atmosphere. The ocean takes up CO2 in two steps. First, the CO2 dissolves in the surface water. Afterwards, the ocean's overturning circulation distributes ocean currents, and mixing processes transport the dissolved CO2 from the surface deep into the ocean's interior, where it accumulates over time. So now there's a carbon sink in the ocean. This overturning circulation is the driving force between the oceanic sink for CO2. This is the AMOC. We talked about this briefly before. This is the AMOC. The size of this sink is very important for the atmospheric CO2 levels. Without this sink, the concentration of CO2 in our atmosphere and the extent of anthropogenic climate change would be considerably higher. Determining what share of the man-made CO2 the oceans absorb has long been a priority for climate researchers. An international team of scientists led by Nicholas Gruber, professor of environmental physics at ETH Zurich, has now determined this oceanic sink over a period of 13 years. As reported in the latest issue of Science, the researchers have found that the ocean has taken up from the atmosphere as much as 34 gigatons, or billions of metric tons, of man-made carbon between 1994 and 2007. This figure corresponds to 31% of all anthropogenic CO2 emitted during that time. That's a lot. And now they say the marine sink is intact. This percentage of CO2 taken in by the oceans has remained relatively stable compared to the preceding 200 years, but the absolute quantity has increased substantially. This is because as long as the atmospheric concentration of CO2 rises, the oceanic sink strengthens more or less proportionately. The more CO2 is in the atmosphere, the more is absorbed by the oceans until it becomes eventually saturated. So far, that point has not been reached. Over the examined period, the global ocean continued to take up anthropogenic CO2 at a rate that is congruent with the increase of atmospheric CO2. Regional differences. Here's the results of 2 surveys, and so on. So we can see where the sinks are. Let's look at that a little bit bigger. So here's the Atlantic Ocean, and the yellow is the highest. So once you get into the reds and oranges and yellow is the highest, and so we can see that the carbon sink in the Atlantic Ocean is the highest between the United States and Spain and northern part of Africa, and then in the South Atlantic it's highest between like midpoint South America over to southern Africa. I would think there would be a huge sink in the Pacific too. Well, there is one. It's not in the yellow yet. It's only in the red, coming all the way across in the South Pacific, and then it kind of fades out before it hits South America. But it's like all the way from Africa to Australia, and then past Australia through almost to South America. This is down to a depth of 3,000 meters. So there's that. Increasing CO2 content acidifies marine habitats. By moderating the rate of global warming, the oceanic sink for man-made CO2 provides an important service for humanity, but it has its price. The CO2 dissolved in the ocean acidifies the water. Our data has shown that this acidification reaches deep into the ocean's interior, extending in part to depths of more than 3,000 meters. This can have serious consequences for many marine organisms. Calcium carbonate spontaneously dissolves in acidified environments, which poses a hazard to mussels and corals, whose shells and skeletons are made of calcium carbonate. The changing chemical composition of the ocean can also impact physiological processes such as the breathing of fish. Documenting the chemical changes imparted on the ocean as a result of human activity is crucial, not least to understand the impact of these changes on marine life. Well, that's the end of the article. So, that study, they took data up to 2007, and if they took data now, that's been 12 years ago. I'm sure it would be 10 times worse. That's just, so anyway, that's what they found, and I found that an interesting study. And so the more carbon dioxide that goes into the ocean, the more it kills marine life and everything else, and also heats up the ocean. You can talk about that. Okay, here's our next article from sciencealert.com. That Pacific anomaly blob now has a distinct cost on animals, not just weather. Remember the blob? I wish that wouldn't do that. Let me see if I can keep my picture. No. Well, you just have to remember the picture. Let's go back and see if there are any other pictures we want to see here. It looks like these are all words. So remember the blob that was in the Pacific Ocean? Well, it's still there. And now they're saying it all looked so promising. And 10 years ago, a survey of mother humpbacks and their calves showed their numbers were on the up off the coast of Maui, Hawaii. Something has changed, with encounters plummeting by 3/4 since 2013. Of course, there could be a number of reasons, but the timing matches the appearance of a vast patch of warm water in the Pacific nicknamed the Blob, and it's too much of a coincidence to ignore. From 2008 until early last year, researchers from the Kaiki-Kohala project in California State University would sit in the Au Channel through the winter months and wait to bump into passing humpbacks heading north to feed. Of particular interest were mothers with newly born calves heading up from the warm southern waters, whose numbers would provide a fair indication of the health of whale populations in coming years. For the first few years, those statistics looked pretty good. The 2013 season saw on average, a mother with her calf close to every 3 kilometers or 1.9 miles, which is roughly triple 2008's numbers. Warming waters around the Arctic have kept ice from returning quickly in the winter months, extending the feeding season for krill connoisseurs like the humpback. Those few halcyon years didn't last long. Bumping into a newborn has since become increasingly rare. Combined figures for 2017 and 2018 saw on average a single pairing about every 12 kilometers. So anyway, they're saying that the whales are not coming back because the water's warmer. The water is warmer and there's less krill, and so the blob is still there. And said that blobs are looking like the new norm, and in spite of the promise of Arctic feasts, whales might face many more challenges like this one when it comes to growing their family. So there's that story. And I've got one more. This is from phys.org from March the 20th. Thawing permafrost produces more methane than expected. You know, we kind of knew this, but people love to hear about methane and thawing permafrost. So this is just another article saying what we've been saying all along. So here's a picture sampling at the Lena Delta in Siberia. Methane, or CH4, potent greenhouse gas that's roughly 30 times more harmful to the climate than carbon dioxide, or CO2. Both gases are produced in thawing permafrost as dead animal and plant remains are decomposed. However, methane is only formed if no oxygen is available. I didn't know that. I didn't know that either. Until now, it was assumed that larger amounts of greenhouse gases are formed when the ground was dry and well aerated when oxygen was available. Christian Knobloch and his colleagues have now demonstrated that water-saturated permafrost soils without oxygen can be twice as harmful to the climate as dry soils, which means the role of methane has been greatly underestimated. Knobloch has, for the first time, measured and quantified in the laboratory the long-term production of methane in thawing permafrost. The team had to wait for 3 years before the approximately 40,000-year-old samples from the Siberian Arctic finally produced methane. The team observed the permafrost for a total of 7 years, an unprecedented long-term study. They found that without oxygen, equal amounts of methane and CO2 are produced. But since methane is a far more potent greenhouse gas, it's more significant. Because methane production couldn't be measured, it was assumed that in the absence of oxygen, only very small amounts of it can be formed. It takes an extremely long time until stable methane-producing microorganisms develop in thawing permafrost. That's why it's so difficult to demonstrate methane production until now. By combining process-based and molecular microbiological methods, our study shows for the first time that the methane-forming microorganisms and the thawing permafrost have significant influence on the greenhouse gas budget. They've used new data to improve a computer model that estimates how much greenhouse gas is produced in permafrost in the long term, and they've compiled a first forecast. According to the scientists, the permafrost soils of Northern Europe, Northern Asia, and North America could produce up to 1 gigaton of methane and 37 gigatons of carbon dioxide by 2100. But there are uncertainties to what depth will the soil actually thaw by then. Will it be wet or dry? One thing, however, is certain: the new data will enable more accurate predictions about the impacts of thawing permafrost on our climate. So there you have it. So you can even get methane with no oxygen from Siberian permafrost from 40,000 years ago. 40,000-year-old samples can have methane, can grow microbes and make methane without oxygen, just given enough time and enough warmth. So those are my articles for today. And and we don't have new methane data. I forgot to say anything. There's no new methane data up on CAMS today. So, and sulfur dioxide didn't look remarkable, so that's why we skipped CAMS. Now moving into our earthquake report. I have USGS pulled up for all magnitudes worldwide for the last 24 hours, and we're seeing 206 earthquakes, which is a pretty high number considering it's the weekend and the quarry blasters most of them are at home. Of those, 36 are 2.5 magnitude or higher. So let's see what's about to come off the map. Well, I think we're okay. I can start wherever I want. So I'm going to start with this big circle here in South America. It was a 6.1 down in Colombia, South America, near El Dovio. It came in this afternoon at 12:21 p.m. Pacific time at 113 kilometers deep. So that's the largest one that we've seen in the last 24 hours. Hopefully that's not in a populated area. It looks like it's just up in the mountains. So, you know, unless it probably didn't do any damage unless it was near, well, it says it's 7 kilometers northwest of El Dovio. That's probably, they're probably okay. So anyway, there's that. Coming on down, there are 4 more in South America. Here's a 4.7 near General Enrique Mosconi in Argentina at 1:11 this morning. Very deep, 533 kilometers deep. So remember, the deep ones are the ones that cause the movement of the plates. 4.1 in the ocean near Taltal, Chile at 10:20 this morning, 36 kilometers deep. 4.3 near Valparaiso, Chile at 12:02 this afternoon, 21 kilometers deep. Coming on across, we have one right in the middle of the Atlantic Ocean, right on the red line. A 5.4 at Central Mid-Atlantic Ridge at 5:35 this morning. Now moving over to the South Pacific, there was a 5.2 in the Kermadec Islands near L'Esperance Rock, New Zealand at 12:47 this morning. All these times are Pacific time because that's my time zone. Indonesia, 4.6 near Dili, East Timor at 10:10 last night. Very deep, 508 kilometers deep. Another one in the ocean of 4.7 near Tobelo, Indonesia at 6:09 this morning. Here was one off the coast of Sumatra, 5.0 near Bengkulu at 1:02 this morning, 35 kilometers deep. Now we see this little wave, and we can go there and see if there was a tsunami warning from that. And the only issue of a tsunami warning from today was from this Alaska, one near Palmer, Alaska. So that one in Indonesia did not create a tsunami warning. But even that one in Palmer, Alaska, it says there's no tsunami danger from this earthquake. So there's that. Coming on around, there were two here in the Indian Ocean, both 5.1, a 5.1 at 4:34 this morning, 30 kilometers deep, and a 5.1 at 4:29 this morning, 10 kilometers deep. But, you know, when we see 10, I think that's the default that they use if they don't know how deep it was, or they don't want to say. So these two 5.1s were within 5 minutes of each other in pretty much the same place because they're stacked up there. Coming on up to China was a 4.1 near Guiegu, China at 6:53 this morning. That's on the Tibetan Plateau. Now this one, 5.0 near Agrihan, Northern Mariana Islands at 3:54 this morning, 102 kilometers deep. So that was in the ocean, so it probably didn't cause any damage. So those are all of the international earthquakes. Now we're going to all magnitudes and look at Hawaii first. We've got 11 here showing today. So I'll just click on them and go around. 2.1, and this was at 6:54 last night at a minus 0.3 kilometers depth. That's at Kilauea. 2.1, 1.9, 1.7, 1.8, 1.9, 3.5, that's the biggest one. That came in at 2:13 this morning, 13 kilometers depth. 1.8, 2.0, 1.9, and 2.1. So this is Kilauea, so that 3.5 was on the side of Kilauea. So all of those 1, 2, 3, 4, 5, 6 were right there in the Kilauea, right on the side of that and in the crater there. So there's that. Now let's hop over to the Dominican Republic. We're showing 10 here today. I'll call them off. 2.0, 2.5, 1.9, 2.5, 2.0, 2.8, 2.1, 3.0, that's the highest one, and 2.1 and 2.4. So those weren't big enough to cause any damage, but it's showing movement. Now let's move on up into Alaska next. And we're showing 56 here of all magnitudes. And Alaska averages between 50 and 100 earthquakes a day. And I want to start with these two, or these down here on this red line. This is where the San Andreas fault line extends and comes up the coast. We've had quite a bit of activity here. 2.5. Here's a 2.4, 2.6, and 2.5. So we got 4 right there, and they're all at 0 kilometers depth, and they started at 10 o'clock last night, and the last one was at 4:16 this afternoon. So that's significant. Here's another one on that red line, a 2.0 near Yakutat at 8:20 this morning, 0 kilometers depth. Now these down here were near Gustavus. And then another one, here's 1.9 near Cape Yakutaga at 10:58 last night. Then coming on into Alaska, here's a 2.3 King Salmon. Here's a 2.0 Anchor Point, 2.1, 2.2. So most of these are 2s. 2.6, that's a little higher. And then these little ones are smaller. Now see, Anchorage is ramping back up a little bit. Now here was a 4.0. That's the biggest one up here today, I think. So that's in the Anchorage area. 4.0, they're calling it near Big Lake at 8:14 this morning, 41 kilometers deep. And then the rest of these are small in the ones. Looks like in the ones range. So there are 20 right there today. So little ones lead to bigger ones. Remember that. They can. 2.5 Sutton Pine. So 2.0 Talkeetna. What's this? 2.2 Willow. So a lot of in the 2s range. Here's a 2.0 Valdez. And then they're peppered around. Here's a 2.9 Unalakleet at 4:07 this morning. Here's a 2.7 Tanana. Now up here at Kobuk, we have 7 here today. I'll call them off. 1.9, 1.6, 3.1, that's getting up there. 2.8, 2.6, 2.8, 2.7. So mainly 2s there, and then that 3. And then one up at the top, a 2.3 near Koktovik. So there's Alaska. seismically active area. Now coming down into the lower 48. We've got 2 down here in Texas. We've got a 2.8 near Pecos at 7:04 this morning, and a 2.5 near Van Horn at 10:38 this morning. Now, moving on up. Okay, nothing being reported in Utah, Wyoming, Montana, Idaho. It's like, what's wrong with this picture? That is way too quiet. That is way, way too quiet. You see that? That's kind of freaky. Normally we see something, even on a Saturday. And we've got 2 little itty bitty ones being reported up in Washington. We've got a 0.8 up there near Poulsbo, and a 0.8 down here near Long Branch. Nothing being reported in Oregon. Moving on down, California. Here is one right off the coast of Petrolia, a 3.5 at 11:20 this morning. Here's a 2.0 near Alder Springs, right there. Looking at the geysers, there are 37 here today. 2.2, that's in the higher range. 2.1, most of them are under 1. Here's another 2.1 and 1.8 came in at 6:09 just now. Let's come on down. Here's a 1.7 near Danville at 4:16 this morning. Following this San Andreas fault line, 1.2 Tres Pinos at a minus 0.4 kilometers depth, meaning it's up in the mountain. 2.2 Pinnacles. 1.4 Parkfield. 0.6 Parkfield. 2.2 Kalami. Moving down into Southern California, 1.1 near Costaic. Now in Southern California, we've got only 27 on the map today, so that's not very many at all. And the largest one, it looks like, is this 3.0 near San Jacinto. This happened at 3:11 this afternoon. Let's see if that's the only one down there. Yeah, and then there's one. Okay, that's at Goldfield, Nevada. So I just didn't want to miss any of the big ones. And also, we had one right next to it, a 2.3 at 3:11. So they were both at 3:11 and at 46 seconds. So they were at the same time. 2.3 and 3.0. So coming in pairs. Here's some down in Baja. Here's a 2.1 near Campo, California. 2.9 near Ensenada, Baja. That one happened at 5:19 this afternoon. Here's a 2.4 near La Quinta. That's in the higher range. So the rest of these are under, probably under 2s. That's a 1.1 there. So rest of them are small and peppered around. Now coming up this middle and east side, 1.2 Ridgecrest, 1.7 Kernville. Oh, we've got a cluster here at Coso Junction. We've got 3 here. We've got a 0.5, a 1.0, and a 0.8 at Coso Junction. So that's slowing down a little bit. I showed that one. Coming up at Mammoth Lakes, we've got 2, a 2.2, and a 0.5 at the same place. Very quiet, very quiet. Now, see if there's anything else further north that we need to look at. Nope. Coming into the Reno area, 0 magnitude near Truckee, and 1.3 near Truckee. Here's a 0.1 near Verdi. Here's a 0.4 near Incline Village. And look at this. This swarm or cluster of 10 up here at Cold Springs. Look at that. They're all in a line, almost a straight line down. That's kind of weird. Starting at 6:44 last night and going to 2:22 this afternoon. And we've been seeing them there for the last few days. So I'm going to call these off. 0.4, minus 0.2, 0.3, 1.0, 0.4, 1.2, 1.2, 1.4, 0.2, and 1.4. So I don't know what's going on there, but it's not that far from Reno. It is northwest of Reno. Okay. I think I got that one, Incline Village. Coming on out here, there was one near Fernley, a 1.4 at 7:07 last night at 0 kilometers depth. It's actually just to the east of Pyramid Lake. I know exactly where that is. It's in these mountains, and the road goes up here. I know where that is. And here's a 0.4 near Fernley at 5:21 this morning. This was directly east of Fernley. Anything else in northern Nevada? No, I think that's good. Down here, here's one at Hawthorne, a 1.5. Now, Goldfield has 8 here today. Let's call them off. 0.8, 1.0, 3.3. That's the highest one. That one happened at 12:34 this morning, 7 kilometers deep. 0.7, 0.7, 1.6, 1.1, and 0.8. That one came in at 5:05 this afternoon. So we've been seeing activity down there. We've been seeing these clusters down there every day for the last week or so. And then we just have some little small ones in southern Nevada, 3 little small ones. So I think that is a wrap. Oh, look what happened over here. Just got a new one. A 2.8 near Mentone, Texas at 6:03 this evening. Right next to this one. This 2.5 near Van Horn. Wow, look at Alaska. It looks like Christmas. See what's going on up here. Look at all of these that just came in. 6. These all started. Okay, I showed that 2.5. I think I showed that. I showed that 2.7 at Kobuk. That was at 5:40. It's 6:34 my time right now. Sometimes it takes a little bit to get these on the map. So 2.5 Sutton Alpine, 1.3 Anchorage. That was at 6:01. 2.0 Anchorage Point at 6:09. 2.4 at Talkeetna at 6:14. 2.1 Big Lake, that's Anchorage, at 6:16. 1.5 Big Lake at 6:17. So I imagine that's the movement. It's getting that movement from that big earthquake down here, and it's causing this plate to move all the way around. That's my thought. It looks pretty red. So, I think that's a wrap. So I love you guys. And I recommend everyone get serious and get your spiritual house in order while you still can, because no one knows the day or the hour, and time is very short. So until next time, God bless, go in peace, and good night.